This is the pretest for Unit 6, which is all about systems of equations. Now, our first 4 questions ask us to graph each system and then determine the number of solutions that it has. And if it has one solution, then we're going to name it. Now, for our first question, both of these equations are in slope-intercept form. So slope-intercept form is an equation of the form y equals mx plus b. So the number in front of the x tells you the slope, and the b tells you the y-intercept. So for our first one here, if we look at the n number, we can see this one's -1. That means our y-intercept is -1. So if we go down here, then that's where the graph starts from. Now the slope is the number of x's that we have. Now there's no number in this question, which means that actually this is just 1x. Now when we want to plot slope from a previous chapter, we do rise over run. Now if there's just a single number, we can write it over 1, because 1 over 1 is still 1. And then we can work out what the slope's going to look like. So I'm going to rise 1 and run 1. Rise 1, and when you do the run, it's always to the right. And then you just repeat this. Up 1 over 1, up 1 over 1. And then if we join this up with a straight line, that's our first equation done. Now our second one is -x plus 5, so the last number, the one without the x, tells us where the graph starts from, so this is +5. Oops. And this time the slope is -1, or -1 over 1, which means this time we go down 1 across 1, down 1 across 1, down 1 across 1, down 1 across 1, and then we can join these up also with a straight line. And the point at which they intersect is the answer to this question. So this one, if I draw it a little more accurately, is this point here, 1, 2, 3, so 3 across and up 2. So our answer for this question is 3, 2, or if you prefer, x equals 3, y equals 2. Now you can also check that answer by substituting back. So if we plug x as 3 into here, 3 minus 1 is indeed 2. And if we check on this one also, -3 plus 5 is also 2. So we know for sure we have that question correct. Now for our second one, this one starts at 2, so I'm going to move to 2 on the y-axis. And we've got -4, which I'm going to write as -4 over 1. So I'm going to go down 4 squares, across 1 square. And it's kind of hard to do that any further, so I'm just going to have to connect these 2 points up here. And for my other equation, it's 2x minus 4, and this one actually goes a little bit off the graph, so just 1 square below. So I'm going to start from here, and this one goes +2, so 2 over 1, it goes up 2, across 1, up 2, across 1, up 2, across 1, and so on. So if I join this one up, I can see that it goes through this point here, which is 1 and -2. Now for our third one, it's in standard form. Now there is a way of graphing standard form by using x and y intercepts. I normally prefer to do this by rearranging into slope-intercept form, so I'm going to go ahead and do that part again. So 2x minus 3y equals -6. First of all, I'm going to subtract 2x from both sides. So I've got -3y equals this, and then I'm going to divide throughout by -3, just so I end up with +y. So y equals, now 2 negatives make a positive, and 2 divided by 3 doesn't simplify, so that would be 2/3 x. -6 divided by -3 is +2. And then now, as it's in slope-intercept form, I can graph just like I did in the previous 2 questions. So start with your y-intercept, which is 2. And then 2 over 3 means I go up 2, across 3, and then I should be able to join this up. And for the other equation, this one's actually already in slope-intercept form, so that's going to be helpful. It starts at 2, and this one goes down 3 across 1, and you can already see where this is going to intersect. It's actually going to intersect on the y-axis itself. So this coordinate here is 0, 2. Now for number 4, both of these are in standard form, so if I can try rearranging this one, I could bring subtracting x from both sides, and then divide both sides by 2. Make sure you divide each term by 2 again. So I get y equals -x over 2, which is the same as -1/2x, and 6 divided by 2, which is 3. So I got -1/2x plus 3, so it starts at 3, and then it goes down 1 across 2, down 1 across 2. With it being negative slope. then for the other equation, I need to subtract 3x from both sides. And then divide by 6. And make sure I divide each term by 6. Now, negative 3 over 6 is actually also negative 1/2. So that tells us that these lines are parallel because they have the same slope. The difference is going to be that 8 divided by 6 is 4/3, which is approximately 1.3. So that intercept's going to be down here. But these two lines are actually going to be parallel, so they're never actually going to cross. So the answer for this one is no solution. Now, another question to keep an eye out for is one where it's not no solution, but actually where it's infinite solutions. Now, I could have spotted this was no solution actually a lot quicker just by looking at the equations if it hadn't have said graph. Because I notice here that these values are times by 3, x times 3 is 3x, but also 2y times 3 is 6y. However, 6 times 3 is not 8, so I know that it was no solution. Now, if this question had said 18, then these lines would actually be identical, this one just being a multiple of this one. And when that happens, you can say that it's infinite solutions. Now, question 4 we have to solve by using substitution. And substitution, normally one of the equations says x equals or it says y equals. So this one says x equals, so wherever we see x, we're actually going to write 2y. So if we look at the other equation, where it says x, I don't write x, I write the other term, which is 2y. The rest of the equation, I just copy down. Now if there's any simplifying I can do, I do so. So 2y plus y is 3y. And then we can divide both sides by 3. And we get 1. Once you've found one of the solutions, substitute back to find the other solution. So for this one, if I plug 1 into the bottom equation, 2 times 1 is 2. So in other words, x equals 2. Now for our other equation, once again we have x. So wherever I see x, I'm actually going to write down 3y minus 2 instead. So 3x, I'm going to put 3 times x. And instead of the x, I'm going to put this 3y minus 2. Notice I've put it in parentheses. I should also have done so on this one as well, but it was just a single term, so I didn't need to. However, for this one, I am going to do some distribution, so that's more important for this one. Then if we copy down the rest of the equation, then we can try and simplify this. Let's try distributing here. So this would be 9y. 3 times 2 is 6, and it says subtract. And then I've also got to add 2y here as well. Like terms here. So 9y plus 2y is 7y. And if we add 6 to both sides, we get 22. And it doesn't look like this one works particularly nicely. It doesn't look like we're going to get a whole number there. Let me just check very carefully, make sure I substituted incorrectly, and copy down the question. Oh, here was my mistake. 9y plus 2y should have been 11y. So if we do 22 divided by 11, then we indeed get the correct answer, which is y equals 2. Once we've found the 2, we can find out the x value by plugging 2 back into this formula. So 3 times 2 is 6, take away 2 is 4, and there's your 2 answers to that question. Now for 7 and 8, it says we're going to use elimination. And elimination is a method where you either add or subtract to make 0. And we can only use that though if they have the same number of x's or the same number of y's. Now actually for this choice, we're rather spoiled, because the x's are the same and also the y's are the same. Now I know this is positive 1 and negative 1, but they're both 1, so that's what I'm most concerned about. Now if they're the same, we're going to subtract, and if they're different, we're going to add. So as these two are the same, I'm going to subtract to get rid of my x's. Now we've got to be a little careful with the y's here. I have 1y, take away negative 1y, which is positive 2y. And 13 take away 5 is 8. And if I divide both sides by 2, I end up with 4. If I then substitute that value back into one of these equations, I'm going to go with the top one because these are all positives. X plus, and instead of putting y, I'm going to write what y is. And then subtract 4 from both sides. And I have my 2 solutions for that question. Now for question 8, also I have 2y and 2y. So these are the same, so I can go ahead and just subtract here. So 3x take away x is 2x, 8 take away 2 is 6, and then if I divide by 2, I get 3. If I pick an equation to substitute back into, I'm going to pick the bottom one this time because it looks a little smaller. Where it says x, I'm just going to write 3, and then the rest of the equation I can just copy down. If I subtract 3 from both sides, and then divide by 2, then I have my answer. So x equals 3, and y equals -1/2. And that's the answer to the first half of the pretest, numbers 1 through 8.